Hi, and welcome to Naming and Writing Ionic Formulas. What we're going to do today, kind of quickly, is use our charts. We need our periodic table, and we need our ion reference sheet in order to be able to do this pretty well. And I'm sorry that this is crooked, I'm just now realizing that. But what you're going to be expected to be able to do is to be given the names of some ionic formulas and to be able to write the correct formula from the name. And then you'll be given the formulas and you'll have to write the name. So you need to have those two charts in order to do this. This is crooked, it's really bothering me. I'm gonna change it. Sorry, pause while I try to fix this. I don't know what's up with my tripod. We'll see how that works for a while. Anyway, so you're gonna be given names. And you have to be kind of familiar with parts of the periodic chart. So if you look at the first one that's up here, I don't know how well you can see it, it says magnesium fluoride. So when I see fluoride, I know that that has a suffix on it that sounds like it's going to be a non-metal that I know. And it is, it's fluoride. So what I need to do is I need to take my periodic chart, and if you haven't done so already, you can actually put the charges. So like everything, there's a trick. Everything in group 1 has a +1 charge. Everything in group 2 has a +2 charge. If you come over here to group 13, from aluminum on down, that's a +3. And then you go to the other side of the chart. So over in group 17, everything is a -1. In group 16, everything is a -2 until you get to the line that separates the metals and the non-metals. And then the same thing with group 15. Group 15, everything is a -3 until you get down to the line that separates the metals and the non-metals. And those are some of the tricks. Now, anything that's in the middle, they have to tell us or we have to figure it out. But those are the tricks for groups 1, group 2, group 13, group 17, 16, and 15, just to the line that separates the metals and the non-metals. So back to what we were doing. Magnesium. Now, frequently, students get magnesium and manganese mixed up. Don't do that. Manganese is Mn, has all kind of different charges. Magnesium, though, is Mg, and if you look at your chart, it's located in group 2. So you write down magnesium, and then because it's in group 2, it's going to have a +2 charge. So you write that down, +2. Okay, and then you have to find the fluoride. So when you find the fluoride is going to be F. Fluoride really means fluorine, and that's going to be in group 17. So in group 17 is fluorine, so that's going to be an F. And it has a -1 charge. And so what you have to do is you have to be able to balance those out in the correct formula. So you have to think, well, why does it have to balance out? Well, magnesium has a +2 because it loses 2 valence electrons. That means that each one of those valence electrons has to have somewhere to go. And so it's going to go to the non-metal, which is going to accept the electrons. That's what makes it negative. It has an overall negative charge. So each fluorine will accept 1 electron. The magnesium will give up 2. So what we're going to do then is write the correct formula like that. 2 fluorine will balance out 1 magnesium. You can think of it like math. So there's 1 times a +2 is a +2, and 2 times a -1 is a -2. So +2 -2, 0, and everybody's balanced. The way that I did this when I was in high school is I would take the charge off of the negative ion and make it the subscript of the positive ion. So there's an understood 1 here. And then I would take the charge off of the metal and make it the subscript of the non-metal. And that works as long as the whole number ratio is the smallest it can be. So this is a 1:2 ratio, and it works out okay. Sometimes the tricks don't work. Sometimes you have a metal that's in the middle of the periodic chart, and then there's no tricks. So tin's located over here. It doesn't have a rule. So that's where these parentheses come into play. The parentheses are Roman numerals, and you really have to know the Roman numerals 1 through 6. That's about all we really use in our class. So make sure you look those up. I think I have them on the PowerPoint as well, but I'm not sure. So we have tin 2. That doesn't mean that there's 2 tins. It means that tin has a +2 charge. What's in parentheses is the charge, and oxide is really oxygen. So you have to look that up as well. So the oxygen is in group 16. That means it has a -2 charge. See, so this is where switching around the charges for subscript thing won't really work because they're both 2s. So what you just have to think about is tin is going to give up 2 electrons and oxygen is going to take 2 electrons. So you just need 1 of each. And that's the correct formula. You always write the positives first. So it's SNO. That's the correct one. That's how you do that one. Now sometimes you have even weirder things. When you see something that has a suffix that's not an IDE, like this was an IDE that told you oxygen. This was an IDE that told you fluorine. That's an ATE. That means polyatomic ion. So you get your chart out and you look at the middle column and you find salt, nitrate, this is nitrate, sorry, nitrate, and gotta be careful because there's also a nitrite. So when you look at nitrate, it says that as a group, it carries a -1 charge. And then you gotta look up lithium. Lithium is Li, and that has a +1 charge. And so this balances out, just one of each. If you needed more than one, you would put the nitrate in parentheses and put the subscript on the outside, but you don't need that for this. It's just LiNO3. In fact, if you put parentheses around that, it's wrong. So only use the parentheses around the polyatomic ions when you need more than one of the group. And that's how you're going to write the correct formulas. Over here, I've given you the formulas and you have to name them. So in general, you name the metal and then you name the non-metal with an IDE ending, if it's not special. So you have to kind of locate the metal on the chart to see if it's special or not. Potassium is in group 1. It's not special. It's always a +1. So you just name the metal, make sure you spell it right, and then you name the non-metal with an IDE ending. So instead of bromine, it's bromide. And that's how you do all the regular ones. This is different. There's parentheses. There's more capital letters. That means it's a polyatomic ion. So you have to look it up on the chart. And you're just gonna have to just go down the chart in the middle until you find OH. There it is, about halfway down, a little bit more than halfway down. And it says that OH is called hydroxide. Strontium's not special, it's in group 2. So you just write strontium, and then you name the polyatomic ion. Hydroxide is one of those weird ones that actually ends in IDE, but it is a polyatomic ion. And notice how to balance out, we needed 2 of the hydroxides to balance out the strontium, so there are parentheses around that. So when you're writing the formulas, you need to remember that. The last one is a special metal. The special metals are listed on the first column of your ion sheet. And so the way that I know that it's a special metal, copper is in the middle. It doesn't have a rule. Copper is a transition element. It doesn't have a specific rule because of the group number. So it could be different versions of the ion. It could be a +1 or a +2, and I've got to figure it out. Well, the way you figure it out is by looking at the other atom. So oxygen is always -2. And there's just one of them, so the overall charge on this was a -2. That means that these 2 coppers, there are 2 coppers, they must be balancing out that -2. So each one of them must have a +1. +2 altogether balances out this -2. So each copper ion has a +1 charge, and so when we write it, we put the name of the metal, copper. We put the charge in parentheses, not how many there are, that's very confusing. We put the charge in parentheses, and then we put the non-metal with an IDE ending. So really, these are all the different examples of all the ones that you could have. We've done a lot of worksheets on this, and if you've uploaded yours, then I probably gave you individual feedback. The biggest mistakes that I find that students make, they use parentheses when they're not needed. They forget to put the IDE ending on the non-metal. They choose the wrong polyatomic ion because like sulfate is SO4, but sulfite is SO3. Nitrate is NO3, but nitrite is NO2. So you really have to pay attention to detail. Misspelling fluoride. Fluoride is FLUORID. That's misspelled all the time. Getting magnesium and manganese mixed up is a big one. I think that's about it. So hopefully this helped and you'll be ready for your quiz.